recording. Okay, so what are we going to learn today? I had sent a message in the group. Hey Dave. So I sent a message in the group mentioning the topics for the day. So yesterday we did a quick review of how was the test, what preparation we need to do, and how do we better manage our time. So now one thing is for sure, that whatever we'll do hereafter, we'll always try to be a little more sensitive about the time that we are taking, so that it becomes a part of each and every problem that we solve. So once we get used to this style of doing things, where we're not only focusing on solution but also being cognizant of the time, that will help us be a little more prepared. Okay, so, and again, no matter how much time we are taking, okay, time is certainly important, but time comes secondary, meaning first thing would be getting the right solution, and then we will try to make sure that we are optimizing the time that we are taking. Okay. Hey Vishwa. So summary is, anything and everything that we do, we'll try doing it right, we'll try doing it accurate, and then add the extra flavor of optimally using the time. Okay. So today we are going to talk about inequalities and related word problems. And you guys might think that, okay, this is something that we have done 100 times. And that is true, we have done it 100 times. But then today our focus would be on those tricky, verbose, complicated looking word problems on inequalities, and see how we are doing justice with that, how we are able to get it right with the minimal time needed. Okay? Is everybody ready to get started, or you guys need some water, some deep breath? All good? Okay, all right. So, what do we mean by inequality? If somebody has to explain that to me in 30 seconds.
It's like a linear equation, except instead of being equal to something, it will give you like a range of answers.
Okay. Yes, Dave. Tell me
I
how.
would say like it's like a linear equation too. It's just instead of having one outcome, it has multiple amounts of outcomes.
Okay. Okay. Is everybody okay with that? And Dave and everybody on the screen, were you guys able to hear what Praneeth said?
Yes, a little bit.
A little bit. Yeah, because Praneeth talks very slow, very different from the way I talk. So is the case with Arush. He also speaks very slow. They are not as loud as I am. I mean, I'm not asking them to change their behavior, their personality, but yeah, saying it a little louder will make it better, easier. Don't take stress for that, but yeah, that's a change that you would want to do, because you guys are going to be in front of a larger audience as you grow, and you would certainly want to be heard. Okay, all right. So, like everybody said, inequality is like an equation, like a linear equation, where instead of one solution you have multiple solutions. I would take the part linear equation out of the equation itself. Inequality could be for linear equation, for quadratic equation, for polynomial, anything. Okay, so there is no limitation as such. Now, for the sake of simplicity, we'll deal with linear equation to begin with, and then we will go deeper into it and see how it changes the way we look at things. Now if I say, I bought mangoes, and the mango season just got over, and mango was like $5 a pound. Okay? So let's say if X is the price for mango for a pound, I'm saying $5. 1 pound of mango cost me $5. Now, you went to a super expensive store and you said that every mango or every variety of mango that you find in the store is more than $5 per pound. So you will say price of mango is more than $5. So you might get mango, a pound of a mango for $6, $5.2, $7.5, $9.2, $20.5, or if the mango is made of gold, probably $2,000 for a pound. So basically you're not limiting yourself to one absolute value. You're saying that this is my condition where this is greater than or less than or greater than equal to. So when you're dealing with multiple options, multiple solutions in an equation, that is when you're talking about inequality. Equality is like something like point blank. You're saying, okay, this is what it is, right? If I tell you guys, I don't know what is so interesting I find about my age, but if I say that my age is 49 years, that is point blank. There is no discussion, no debate, no bargain. If I say my age is more than 45 years, I'm leaving that for you guys to kind of guess and assume based on certain understanding that you guys have, right? Who joined in between? Rehan. Hey Rehan. So Rehan, we're just starting with inequalities and related word problems, and you will see a lot of interesting facts to it. So basically, inequality, when you're talking about, you're saying that you're not restricted by one answer. You have multiple options to choose from, and it could be for linear equation, it could be for quadratic equation, or any variety of equation that we are aware of. Is that okay? Hello, Saranya. Okay, so let's move on. So now, instead of dealing with the price of mango, let's go a little further into it. If I say x plus y equals 8, that means you're saying that you're looking at combination of x and y value which will add up to make 8. If you say x plus y is greater than equal to 8, then you're talking about all possibilities where x and y add up to be 8 or more. So in this case, the number of options that you'll have will be limited. In this case, you'll have a little more options. So if you try visualizing this in a coordinate plane, if you're talking about this guy, x plus y equal to 8, you will put a small table x and y values. Let's say x is 1, y is 7, x is 2, y is 6. 1, 2, 3, 4, 5, 6. 4, 6, 8, 12. 1, 2, I'm using different scales. So when x is 1, let's say y is 7, somewhere here. X is 2, y is 6, here. And this is the kind of a line that you're talking about. But each and every value of x and y will lie on this line. As soon as you go to inequality, you are expanding your horizon and it will not be limited to the line. Only this part will be falling on the line. The greater than equal to, you will have to choose which way it's going. Is it covering the entire space this way or this way? That we'll deal with and we'll come to that, okay? No, Tansi. Alright, so I'm not going to talk about the inequality concept separately. It is something similar to what we have dealt with linear equation or quadratic equations. Let's look at some of the word problems and then relate that with inequality and see how that is working for us. Is that okay? No damage done so far? Okay, let's move on. So, me cooking up questions on the fly, obviously is not bad, but let's look at some legitimate questions that you will come across and see how we are dealing with them. So today you will observe one difference. I keep taking off my glasses while I'm trying to read something, but today I'm better off. I changed my glasses. I should be able to see things better without taking it off. Let's see. Okay, see. Let's look at the first problem. Okay, and pay attention everybody here. The question is, Anna is considering 3 insurance options for her business, shown in the table. So she has 3 options in the table below. option 1, 2 and 3. And then this is initial cost. This is deductible. And then first one says $1425, deductible is $450. Second one is $1700, deductible is $250. Third option is $1975, deductible is $50. So Anna, somebody with name Anna is considering the insurance option, and there are 3 options that she has. One option is where the initial cost is $1425, deductible is $450, $1700, deductible is $250, $1975, deductible is $50. And for some of you, if you are not aware what is initial cost and what is deductible, any insurance that you take, let's say we all have car insurance. So we pay a premium, this is the cost, and deductible means when something happens, what is the minimum amount that you have to pay? Okay, let's say for the car insurance, if my deductible is 500, meaning if I come across an accident or if I have to go for some repair, 500 is what I have to pay. In this case, 450 is what I have to pay from my pocket. Everything else will be paid by the insurance company. If I am paying a higher premium, my deductible is coming down. Insurance company says you pay me more and you have to pay less for your services or repair. That is the case here. Now let's look at the remaining part of the question. Okay, see, I'm so much tempted to take my glass out for reading things, even if I'm able to read. So there are the options given. Then it says, she wants the total cost C plus D. So this is C and this is D. She wants the total cost to be most $2,000. So the maximum total cost she wants is $2,000. She also wants the benefit, which is 90% of. The benefit is 90% of 10C minus D. So this is C initial cost, this is D. To be at least $12,400. There are a lot of information, okay? I would certainly want you guys to pay attention to what we are discussing right now. Which of the following option selection would fit Anna's plan? Option A is 1 and 2 will work. Option B is only option 2 will work. Third choice is only 3 will work. Fourth choice is none will work. So if I read the question for you guys one last time, it says Anna is trying to choose between different insurance options, and there are 3 options she has. First option is this much initial cost, which is called initial cost is called C, and the deductible is called D. There are the 3 options that she has, and she wants to make sure that she wants the total cost C plus D to be at most $2,000. So these two together has to be at most $2,000. That is the first condition. Okay, I'm depending on the budget. And second thing is she also wants the benefit, meaning benefit has to be 90% of 10 times C minus D, of 90% of this value, and that has to be at least this much. Meaning 10 times the cost minus the deductible, 90% of that should be at least this much. Now you guys must be thinking that why this is important. So this is how they calculate benefit, that how much you are paying initial cost and what is your deductible, and they have put up a calculation, sales put up a calculation saying that 90% of this thing has to be at least this much. Now you have the entire world at your disposal. You have to find out which option will work for her. Yeah.
Does this say 10,000? No, it's 2,000 over 10 C minus 2.
No, it says 10. It just says 10 C minus D. Her benefit, this is the benefit part of it.
Okay.
Does she want both to be at least 2,000 or at most 2,000?
No, this one says this has to be at most 2,000, meaning she wants to control her expenses, okay? This has to be at most 2,000, meaning whatever I'm paying and then this together has to be at most $2,000. And it's not saying how many times she's going for repair or services, okay? It just says it has to be at most this much, okay? And then she also wants the benefit, which is 20% of this thing, to be at least this much. Yep,
It's not.
it's none. Okay, I'll come to you. I mean, if you guys heard what Davik said, ignore. Do your calculation and tell me which option you are leaning towards. I'm assuming everybody heard the question right. Did everybody hear the question?
Just repeat it one more time.
Okay, I'm Anna for next 5 minutes. I have 3 insurance options to choose from. First option is where, okay guys, somebody is trying to listen to my question, okay? First option is where the initial cost is $1,425 and deductible is $450. Second option is initial cost is $1,700, deductible is $250. Third option is $1,975 as initial cost and $50 is deductible. Initial cost is called C and deductible is called D. So what I as Anna, I'm trying to make sure is my C plus D has to be at the most $2,000. I cannot go beyond $2,000. And second thing is I also want benefit, which is 90% of this thing. 90% of 10C minus D, and it has to be at least $12,400. So then, based on these conditions, I as Anna, I'm trying to figure out which option will work. 1 or 2 both will work. Option 2 only will work. Option 3 only will work, or none will work based on the condition. Yep.
Do you say it has to be at most 12,000 for
At least.
at
This
least?
is at least, this is at most. Yep. So basically, this is benefit. So benefit has to be more. This is cost. Cost has to be less. Yeah.
Okay.
You want to go for A? Okay. Tansi, did you hear the question, beta?
It has to meet both of the requirements, right?
Yeah.
Wait, is
Yes,
it
sir.
12,000 or is it 2,000?
12,400.
12,400. It has to be at least this much, meaning you want the more benefit. And this is your cost. You want this to be at most 2,000.
Yeah. A still.
Is play. Okay. I'm liking how you guys are debating this. That's a good idea. You also think it's A? Okay. I'll come back to you guys to understand why you're leaning towards that option. How about Viswa? Oh, Viswa told the answer. Nikhil, Rehan, Riya, Ritika, Saranya,
In order.
Vishal,
And none of them.
Dev,
12,000.
Neil and Sarah. What's going on in your mind?
Sir, what does option 2 say?
It has to
Option
be
2 is this.
10C minus D.
Option 2 says initial cost is $1,700 and deductible is $250.
Oh shoot, I think they're wrong.
I'm sorry, Dave?
I think
It's A. Riya, Ritika, what's cooking up?
I'm still working on it.
Okay. Saranya,
It should be more than 12,400, right?
it should be, yeah. This is the benefit part of it. So it says it should be more than this.
I'd like to change my answer to A.
You want to change to A?
I
Okay.
said D
I got A.
originally. But
You
it's
also
A.
you also got A. Everybody is leaning towards A.
I
A.
got A.
Okay.
Calculation.
Yeah, Rehan.
I got it.
You also got A. Okay. Now turn around, guys. Everybody turn around. Okay. So let me. Yes, Vishwa.
Can I be right back, sir? I need some water.
I'm sorry, beta.
I'll be right back, sir.
No worries. Okay. So let's say Rehan, who talks the least always. So Rehan, tell me why you're leaning towards A. What was your technique for getting to A? It's okay, don't have to be shy with me, okay, that's fine. If you are making a guess based on certain assumptions, you have to just call out the assumption, that's it.
There are times the C value for option A is by 10 and then subtracted like the D part of it. And then I got 13,800 and then I did 90% of 13,800, like about 12,420 or something.
Okay. So you met one condition. Okay. Okay. Let's see, Tansi, how did you verify? How did you come to A?
So I just I only did number one. I only solved for number one. And since number one was only in A, I just picked A.
That's also a smart move. Okay. Here, Praneet, Devik, somebody explain me.
So we went through and did the first condition, just make sure to see which ones met the first condition. We found 1 and 2, and then we continued on to the second condition because we need both conditions to work to get to know if it truly is an option. And then we found out 1 and 2 still work for that condition.
Okay. So now there are two key theories that I heard here. Okay. That first one was, if you look at this one, so simple thing that, I mean, if you kind of visualize that in the form of an equation, right? It says C and D, C plus D has to be less than equal to 2000. At most 2000, meaning 2000 included. This is your first equation. Second equation says 90%, meaning 0.9 of 10C minus D has to be greater than equal to, it says at least this, so greater than equal to 12,400. And then you have these two equations, you can figure out how you want to solve it. Or here, hey Jana, here the other technique that I heard from Tansi, she said, okay, 1 is only present in one of the options, that is A. So it might be a situation where, so Jana, I mean, since you have joined just now, we are talking about inequalities and how do we deal with inequality, what problems, little complicated ones, okay? So it's going to be more of a talking, exchanging, deliberating different techniques for doing it right, okay?
Okay, sounds good.
Yeah. So here, what Tansi said, okay, 1 is an option only in one of the 4 choices. She said, okay, fine, let me check if 1 is true or not. If 1 is true, and then correspondingly 2 is also true, then I can lean on this. If 1 itself is not true, then this one is gone, then we'll look at other options. For easiest thing, right, if you look at these two equations, C plus D, initial cost plus deductible has to be at most 2000. These two together, it is less than 2000. 14 plus 4, 1875, less than 2000. First condition is met. 10C minus D, she calculated 90% of 10C minus D, plugged into this one and found that yeah, this condition is also met. So 1 is correct, then she chose that option. The only risk with that is if 2 was not satisfying this, then your answer could go wrong. Okay? Because here for this option to be right, you have to have both the options satisfying this condition. So then that is when all of you, most of you, you validated 1 and 2 both and found that it's satisfying these two conditions. Only 2 would have been this choice. Only, I mean, see, this is 1975 plus 50 is 2025. So 3 is out of equation. So you have only this option, or this option. Now, when you saw that this one and this one is satisfying these both the conditions, you want to rule out this also, and this looks appropriate. 3 is anyway gone. So these are 3 options you had. When both are satisfying, you are leaning on this one. You will rule out this one obviously, and you will rule out this one also. So the time saving technique here would be 2 folds. As soon as you get the question, put this equation and look at this and see which one is satisfying the first condition, because that's the easier thing. And as soon as you looked at this condition, this one got ruled out, then you are left with these two, and then you violated one of this for the second condition, and if you are getting a clear answer, then you violate the second one. That's how I look at it. But then, what will be the technique here? Now look at this one. 10C minus D. What's the difference between this guy and this guy? 10C. 10C in this case is 14,250, and in this case is 17,000. Minus D. Minus D is 450 here. This one is greater than this value, and this minus 250. This is anyway going to be greater than this, but you are not looking at this value alone, you have to look at 0.9 of this. Now the thing is, you have to look for any and every value greater than this. If the first one satisfies, you don't actually have to go to second one. So, little bit of analysis is needed when you read the question, read the data, and then you'll say, okay, fine. If both of them are satisfying this condition, and this one is anyway going to be greater than this whole value for second condition, if this one itself meets, second one will meet by default. So don't just solve problem, always focus on analysis will certainly help you nail it down to the right answer. Let's move on. It's been already almost 30 minutes and we have only looked at one problem. Let's look at other problems and see what kind of a strategy we are applying. But is everybody clear with whatever we have discussed so far? I mean, you guys will probably mock me by saying that you have not told anything, it's only us solving the problem. I was just collating it. Okay? Alright, let's go to the next problem. Jenna, are you with me so far?
Yep.
Okay. Now, let me pick up another problem that is less verbose so that we can do more problems. So I have a graph. This is first quadrant, this is second quadrant, this is third quadrant. I mean, nothing very unique about me. This is how these are. It says, with the system of inequalities, y greater than equal to minus 5 by 2 x plus 1 and y is less than equal to minus 1 by 2 x plus 5 by 2 is graphed in the xy plane, which quadrant contains no solution to the system. So these are 4 quadrants you have, and these are the 2 inequalities you have. First one says y is greater than equal to minus 5 by 2 into x plus 1, and second one says y is less than equal to minus 1 by 2x plus 5 by 2. It says if these 2 inequalities are graphed, which quadrant contains no solution to the system? And you have all the 4 options A, B, C, D.
Is the second equation 1/2 by x or negative 1/2?
Negative half by x. So everybody got the question, right? You had 2 inequalities. Y is greater than equal to minus 5 by 2x plus 1. And second inequality is y is less than equal to minus half x plus 5 by 2. And you have to find out in which quadrant this system of equation will not have a solution. And again, just a clue, just a jump start. When you are looking at inequalities, let's say I plot this one and I get something like this. And it's greater than equal to, let's say, this is talking about this region. If I'm talking about this one, this inequality, let's say, let's plot a line like this, and I'm talking about this region. So then, the quadrant that doesn't have a solution is this quadrant. because here also, okay. So this quadrant and this quadrant also, because when you're talking about system of equations, this is one quadrant where you have both being met. So this quadrant has some solution. This quadrant is anyways covered. This quadrant and this quadrant doesn't have any solution here. So net, what I'm saying is, you have to visualize how your inequality is graphing, which region is talking about, and then when you have a system of inequalities, see which is common for both of them. So here, right, if you're looking at these two inequalities, let's say this one is graphing everything above this, and this one is graphing everything above this. So you're talking about only this part. Let me put that in blue. You're only talking about this blue part, which has a solution from this one. And that covers your quadrant 1 and quadrant 2 both. It doesn't cover 3 and 4. So this is just the going in position just for you guys to relate to it. I would let you guys struggle with this for 5 minutes before I start talking about it. Yep. Quadrant 3. Okay. You also agree to him. How about you, Pranit? Okay. Everybody is agreeing to quadrant 3. But my request to you all would be, don't agree to what the kids here are saying, okay? They are good friends, but they may or may not be right. Okay. I hope everybody got the question at least. I have some strategy in mind, but I will disclose that later. Once I see you guys deal with it by yourself for some time. Maybe another 2-3 minutes. At least get me the approach part, okay? You may or may not get the perfect answer, but get me the approach. Is everybody able to try? Jenna, Rehan, Tansi, Sarah, Neil. Okay. Saranya, are you trying with her? Okay. Ria, are you giving it a shot?
So are we basically just looking like where the point, where the shaded point is?
No, so basically now you have system of inequalities, right? So basically let's say this is one line that is drawn and everything above this is giving me the solution. And second one is crossing like this. And this one has everything above this as a solution. So here, when you look at system of inequalities, I'm talking about everything that is between my two hands. That is what is my solution range or zone. So what we have to find out is, from this system of inequality, which quadrant there is no solution existing, or which quadrant is excluded from the solution options that we get from by solving these two.
Sir, I think I have the answer.
Oh, okay, tell me what the answer is.
Quadrant 4.
Quadrant 4, that is very good to know, because kids here said quadrant 3, you are saying quadrant 4. That makes me believe that we are all trying ourselves. Okay, I'll give you guys 2 more minutes before I start jumping onto it. Jenna, did I answer your question, beta? Yes, Vishwa.
When both of
You also got quadrant 4.
steeper is
Okay.
is
Alright. Ria, Ritika, Saranya, Stansi. What's going on? Vishal. Yes, Ritika.
I think
It's
it's
second.
quadrant 4 as well.
You also got quadrant 4? Okay. Guys, you guys have a problem now. Everybody on the screen is saying quadrant 4. And you guys said quadrant 3. you might want to validate your answer one more time. I mean, I'm not saying you are right or the kids online are right, but opportunity to validate.
Yeah, that's what we're doing.
Okay.
Zero, right? Zero.
There's a very good environment here in the classroom. I see 3 of the kids discussing among themselves, brainstorming the solution, and that's what makes me very happy actually. When I see you guys exchange information with each other, just be little less louder, guys. Just little less loud, little less louder. Okay. Okay. Now let me. Okay. Everybody here. Tell me, how did you solve it? Yeah, one of you.
Pradeep is our representative.
Okay, so we graphed the equation, colored in the areas that were having the solution for each line and found where there's overlapping, and then wherever there wasn't an overlapping one, we found it as quadrant 3.
Okay. How about Ritika? What was your approach, beta? Or Neil? One of you.
I graphed it and
Okay.
the area that didn't have any was quadrant 4.
Okay. So you graphed it, meaning when you guys are saying you graphed it, okay, here, now discussion, let's pause the discussion. So now, when you graphed it, what did you do? You created the table and then you went ahead with that?
We used the calculator.
That's good. Okay. Okay. Now for everybody, okay? The most orthodox approach would be, whenever I have greater than equal to, less than equal to kind of situation, I will just ignore that for a little bit. I'll say first equation will become y equals minus 5 over 2x plus 1, and this one I will change it to y equals minus half x plus 5 over 2, and then graph this line and figure out whether my area is above or below depending on the condition that we have. Yeah. But here I will take a slightly different approach. Why? Because as soon as I read this question, when I'm analyzing it, what I get to know is these two equations are in y-intercept form. I don't necessarily have to see. Nobody is asking me for a point blank answer. It's just asking me which quadrant it covers, which quadrant doesn't. So I'm just trying to be a little stingy here with my time and trying to say that both are in slope-intercept form. This is my slope, minus 5 over 2. Meaning my slope is decreasing. With every increase of x, y is decreasing. That's why it is negative. Meaning when x is increasing, y is decreasing. So it's going like this. Yeah? This one is going like this. Here also is negative. So this one is also going down. Net, what I see is, now, so both are going down. So this is going down, this is going down. Okay? Now, I have the intercept also. Okay, guys, here. You guys are not paying attention. I have the y-intercept also here. Meaning, one of the line has an intercept of y equal to 1. This is here. And second one has an intercept of 5 over 2. That is 2.5, let's say. So one line which is having a higher negative of the slope, meaning this is decreasing very fast, is going through this one, and second one which has a lesser negative slope, meaning it's decreasing slowly, going through this. Okay? So it is not going to third quadrant for sure. But we have not concluded yet. This one, intercept 1, is greater than equal to this. Okay? Now let's look at any point. Let's say I'm picking up a point 8, 6. Okay? 8, 6. When I put x equal to 8, and y equal to 6. So this is 6 is greater than equal to minus 5 over 2 times 8. So minus 5 over 2 into 8 plus 1. This is minus 40 over 2 minus 20 plus 1 minus 19. 6 is greater than equal to minus 19. So yeah, this region is okay for this guy. This guy is talking about this zone. Okay. So quadrant 2, quadrant 1, quadrant 4 all are covered here for the first guy. Now for this guy, same 8 and 6. If I substitute here, y6 is greater than equal to minus half of x, half of this 8 plus 5 over 2. So minus 4 plus this minus something or maybe 1 or 2 is greater than 6. That is not correct. So this point holds true for second one, but not for this guy. So this guy is below this. Okay. So what is common here that you see is only this zone. Okay. Meaning it covers little bit of quadrant 1, quadrant 2 and quadrant 4. What it doesn't cover is quadrant 3. Now, I might have gotten everybody confused here. Did everybody understand what I was trying to do, or? I'm sorry, Vita? Yeah. So, okay. Let me try solving it one more time. We have just two systems of inequalities. Okay? Everybody here. Jana, Dev, Neil, Sara, everybody. Vishwas, everybody. So these are two systems of inequalities we have. And we have to find out. And the question says, when you solve this one, find out which quadrant doesn't have a solution. Okay? 1, 2, 3, 4. Now, when I look at this one, this is y is greater than or equal to. So, when we are dealing with any inequality, okay, first thing you have to do is convert that to a simple linear equation, and then we'll figure out which zone it's talking about. So, this one is talking about y is equal to minus 5 over 2, x plus 1. I have kind of paused this information for now. I'm not looking at that. This is my linear equation. And once I graph it on a coordinate plane, I would know whether it's above the line or below the line. Okay. Similarly, the second inequality is y is less than or equal to minus half x plus 5 by 2. I'm writing this as a simple linear equation. I'm just converting this to equal to minus half x plus 5 over 2. So these are two linear equations I have. Now if I look at both of them, both are in the y-intercept form. Okay? Or, okay, let me not confuse you guys. Now I have two lines or linear equations. Let's draw them. Let's plot this one first. X and y. When x is 0, this is y equal to 1. When y is 0, x is equal to 2. So when y is 0, this is minus 5 over 2 x plus 1, or 5 over 2 x equal to 1. So x will be equal to 2 by 5. So 2 by 5 will be 0.4. Okay. So when x is 0, let's say this is 1, 2, 3, 4. 1, 2, 3, 4. When x is 0, y is 1. So this is 1 point on the first line I am talking about. When y is 0, x is 0.4. This is the line we are talking about. Now, looking at this one, since this is a inequality sign, we have to find out whether I am talking about the region above this or below this. So I picked up a point here. Let's say this is 1, 2, 3, and this is 1, 2, 3, 4, 5. 3, 5. I'm just trying to find out whether this is satisfying this condition or not. 3, 5. When I put it here, x is 3. So minus 5 over 2 into 3 plus 1 is greater than, y is greater than 5 is greater than minus 5 by 2 into 3. 5 3 15 over 2 is minus 7.5 plus 1. So 5 is greater than equal to minus 6.5. No denying this. This is correct, right? So that means this region, anything above this line is satisfying for the first inequality. Is everybody with me? Jana, Dev, Vishal, Ritika, everybody?
So, wait, I have a question. So, is it greater than?
This is greater than equal to. So what we do is, whenever you are dealing with inequality, you convert that to a linear equation and then draw the line, and then you have to figure out whether this greater than equal to or less than equal to, whatever it is satisfying the point above this line or below this line. Okay?
So, if it was less than, it would be the opposite, right?
There's no convention that we can follow. What we can do is we can randomly pick a point. Pick a point which is clearly visible. Let's say I'm picking up this point with the coordinates 3, 5. X value is 3, y is 5. I'm just trying to see whether this satisfies this condition or not. So when I put x equal to 3, this became 5 into 3 over 2. That is 15 over 2 minus 7.5 plus 1. That is minus 6.5. And what is the y value? That is 5. So 5 is greater than or equal to 6.5. This satisfies this condition. So then we are assuming that any point above this would satisfy this condition. So we are talking about this region.
Like a test point.
Yeah, test point, yeah.
Okay.
Yeah?
Got it.
So all that is shaded in the dark color right now is satisfying the first inequality. Now let's look at the second one. So now second one, same thing, we have converted that to linear equation, and let's put a table here quickly. And I'll just pick up x and y value when one is 0, what is the corresponding value of it? When x is 0, I put 0 here, y is equal to 5 over 2. That is essentially a y-intercept. Okay, so Bhuvi, you have joined 10 minutes early, beta. You will be overwhelmed by what we are discussing right now. You might want to join after 10 minutes, okay? Now, when you put y equals 0, what is the value of x? Y is 0, that means minus half x plus 5 over 2. That is, x goes to this goes to the other side. X over 2 is 5 over 2, so the x equals 5. When y is 0, x is 5. So you have 2 points here. Now when you put x equal to 0, 5 over 2. 1, 2, 5 over 2. This is your 1 point. And when x is 0, when y is 0, x is 5. So 1, 2, 3, 4, let's say 5. So this is your second point. If you join these 2 points, now you are trying to find out for this line, the second one. I will color that in a red color to figure out which zone this satisfies. If I use the same point, I'm just trying to figure out if this point satisfies the second inequality or not. So 3 and 5. So I'm putting y equals 5 is less than equal to minus half into x, that is 3, plus 5 over 2. So this is 3 over 2 and this is 5 plus 5 over 2. So this becomes, this is 1.5 and this is 2.5. This is minus, this is plus. So this becomes almost 1. 1 is greater than equal to 5 or 5 is less than equal to 1. That is not correct. So point above this line is not true. So for this inequality, anything that is falling below this is satisfying this second inequality. Now when you look at system of inequality, what is the common portion? That is only this, everything in between this. Yeah? So the dark one is above this The red one is below this. So what you have common here is only this part that I'm going to color in blue. The common thing is only between the two lines. And now when you look at this, you find that it has some values from first quadrant, it has some value from second quadrant, it has some value from fourth quadrant. What is not touched here is, see, the third quadrant is completely blank, unused for this system of inequality. So there is no blue part inside this. Did I depict that properly? Rehan, Nikhil, Vishal, everybody? So there are different ways of looking at it, okay? Whenever you have inequality, you'll convert that to equation, draw it, and then identify which area are we talking about, above or below. And Jenna, to your point, there's no silver bullet that we can use, say, okay, if it's greater than equal to, it'll be above, less than equal to, it'll be below. We cannot make it out that way because positive, negative sign and the corresponding values make a lot of difference. Yes, Jenna?
Couldn't you use like the Desmos too, like plug in both equations?
Yeah, you can. Always.
And it will show you the same, right?
Yeah, it will show the same. You can randomly pick any point. See, just to be on the safer side, right? Somebody like me who is very skeptic, I would not pick a point which is very close to this thing. I will pick a point which is far. So that way, even if my drawing skills are horribly bad, I don't have to rely on that. Yeah? See, everybody is smiling as soon as I acknowledge that my drawing skills is bad. People, you guys have been seeing me do all the magic. So, okay. Anyways, but to be on the safer side, always choose a point which is not doubtful, okay? Pick a point which is way too clear to you. Pick a point 10, 10. That's okay. That even if that is not visible on the board, at least you will know whether it's above this or below this. Yeah? Make sense? Everybody with me so far? So, see again, we have just looked at two problems so far. And did I try solving it before the class? If you guys at all believe me, the answer is no, I did not. I just looked at the questions and said, okay, fine, we'll try it in the class. That's why at times I might sound unprepared or underprepared because I cannot memorize math. That is my weakness. And I would not assume anybody to memorize math. You will get different types of problems. It's not like biology where you have to memorize terms, right? It is a concept. We know the concept, what is inequality, and depending on what equation that we are dealing with, how do we apply the strategy and solve it? That would be the approach. So here, when I started, I was saying that, okay, you can also look at both are in slope intercept form, right? If you look at this equation and this equation, both are in slope intercept form. You can also say, okay, fine, this is my y-intercept, this is my y-intercept, and this is a negative slope, this also has a negative slope, this is a greater negative slope, meaning one is changing fast, second one is changing slow, and you know where it's intercepting, the y-axis. So from that also you can see. So the approach that we took, or the approach that I took, was one of the most orthodox and a foolproof method, but that might take a little longer time. In the exam, you might not want to go that detail. You would still want to make a judgment because here it's not asking you for an absolute answer. It's just asking for a reason. So if you look at these two equations and then identify the lines and identify above or below part by plugging some value here, you will be able to make a judgment a little faster without doing much of a calculation also. So this will remain one of the key objectives for us also. Each and every problem that we solve, if you are able to solve it in 5 minutes, we should always challenge ourselves or question ourselves, can I solve this in 4 minutes 30 seconds also? That 30 seconds that you will save, that will help you to do one more problem and improve your score. Yep. So we have 3 more minutes. I'm just thinking that we will not try solving a problem, but we will look at the approach part of it. Just an approach part of it. Let me read a question real quick in 1 minute and then let's see if you guys are able to make use of the remaining 2 120 seconds to give me some approach. This question says 3y is greater than or equal to 18x plus 6, and second inequality says 20x plus y is greater than or equal to 210. If 8 comma b is a solution to the system of inequalities, what is the minimum value of b? You have two inequalities, 3y greater than or equal to 18x plus 6, 20x plus 4 is greater than or equal to 210, and if this is one of the solution for the system of inequalities, what is the minimum value of b? That's what you have to find out. Just tell me the approach. How will you go about it? Yeah.
So I would graph both lines, and since it's less than or equal to, any dots on the lines will satisfy the points. So I would see which line is the lower part, the minimum part of the solution area between the two, and then see what the value of y is when x is 8 on that line, and then that value would be the minimum value of b.
Okay. That will be the most orthodox approach. I mean that's the most, what do you call, the official approach rather. But as I said, in a SAT exam, you will be hard pressed for time. Can you save a minute? Think about it. Let me give you guys a very dumb answer for this one, okay? See, this is one of the solution, okay? Guys, here. Knowing entire concept is very important, but knowing some of the basic dirty tricks are also equally important. Now look at this. This is satisfying the system of equations, okay? That means one value is known to you. X value is known to you. What you're trying to find out is the y value. Plug in this value here. From this one, 3y is greater than or equal to 18x. 8 is known to you. 18 is 154 plus 6. 3y is greater than or equal to 160. Y is greater than or equal to 360 by 3. Like 53.33. This gave you one value, okay? Now look at this one. Again, this has to satisfy this inequality also, correct? X is known to you. 20 into x, 8. 20 into 8 plus y is greater than or equal to 210. So 20 into 8, 160. Y is greater than or equal to 210 minus 160. Y is greater than or equal to 50. This one says y is greater than or equal to 53.33. This one says y is greater than or equal to 50. Choose your best bet. For both to satisfy, this has to be a minimum value. One says y has to be greater than or equal to 50. So 50 is valid, 53 is valid, 54 is valid. This one says no. This has to be greater than 53.33. So that if you combine these two rules, the best answer that you can pick up would be this one, which will satisfy this condition as well as this condition. This will save you 2 minutes, for sure. Did I make sense or I did not? Ritika, Dev, Jana, Tansi. Okay. Now, so I know it might not have made sense to a lot of you because I was just rushing through it. Watch the video of the class, last 5 minutes. See what blabbering I have done and just try relating to it. If it's clear, wonderful. If not, I'm not going anywhere. Catch hold of me. Okay? With that being said, I'll let you guys go. Enjoy the rest of your evening. You have one more day of holiday left. So make maximum use of it. Yes, Jana. Yeah, Jana, you're saying something.
I have a quick question.
Yep.